Just like a pyramid is a prism that has one base shrunk down to a point, a cone is a cylinder that has one of the circular bases shrunk down to the point. So imagine taking this circle and just shrinking it down to one point. That's how you get a cone. Now the shrinking down of the point ends up cutting the surface area, the overall surface area, in half of the cylinder. We add the area of the base of the cone, which is a circle, to the round side of the cone, the area of the round side of the cone, which is pi times r times the height, or slant height of the cone. So you need to know what slant height is to calculate the things you need to know about the cone. And that is this height, this distance right here. Since it's circular, it's always going to be the exact same no matter how you do it, but that's the slant height. Just like I showed in the pyramid with the Pythagorean theorem process, we're going to have to do that again here if we don't know what the slant height is. It's not too hard because you can think of this cone as like triangle. Just kind of ignore the bottom part there. This is just a triangle where you can go like this, or you can drop it straight down. Either way, you get right angles. And you can find the relevant pieces that you need to know for those things. So that's what we're going to end up probably doing. But what we can do is we know that some of the formulas for these things without having to do a lot of other work. So area of a cone is going to be the bottom area of the circle. So the area of this circle here. This is going to be the area of a cone. The area of a circle is pi times the radius squared. So of course, that's the radius. We have pi times the radius squared. We're going to add that to the area of the outside thing. And what that ends up being is pi times the radius times the slant height, s. We have to know the slant height to know what the surface area, I should say surface area of the cone is. Now the volume is, once again, it's probably the easier thing to find. This one is just 1/3 pi times the radius squared times the height. Think of it as the area of the circle, pi times the radius squared, and then 1/3 of the height is multiplied onto that. That's how we change this to a cone. Now this is to be compared to the cylinder, right? The volume of a cylinder is the area of the circle times the height. So you can see that, so this is for the cylinder, this is for the cone. You can see that going from the this process here, changing one of the sides to just a point, that ends up making the volume be 1/3 of what it originally was. Kind of an interesting thing to note there. All right, let's see these formulas used in practice. So this first cone, I know the diameter of the base, I know the height of the cone, and I actually know the slant height, s, of the cone. So first thing we need to do is figure out what is the radius. The radius is going to be half of the diameter, which of course is 15.8. So we get a radius of 7.9. And now the surface area of this cone is going to be the area of the circle on the bottom, which is going to be pi r squared, pi times the radius squared. That's going to be added to pi times the radius of the cone, which is 7.9, and that's multiplied by the slant height, 17.4. That's the formula for surface area. Plugging this in and we get 627.91. That's of course approximated. This is going to be in centimeters squared. All right, for the volume, we have 1/3 pi times the radius times the height of the cone. Again, the height is going to be from the circular base straight to the point. That's why this number there is the height times 15.5. So it doesn't matter if it's on the side, if the cone's on its side, that's still going to be the height measurement. This is going to, once again, going to be an approximation. So 1/3 times pi times 7.9 times 15.5. I'm getting 128.23. And this is in cubed units because it's a volume. All right, that was the first cone. Now the second cone, we have two pieces of information. We know the radius and we know the height. We do not know the slant height. So we do need to find that before we do much else. Let me clean up some space here. All right. We can draw a straight line down the center and go straight out. And that gives me a triangle that looks like this. Now this is going to be our slant height. This distance here, this tall distance here, that's the same thing as the height of the cylinder. And this distance happens to be the exact same thing as the radius. So that's going to be 15. To find the slant height, well, the slant height is going to be the hypotenuse. That means this is going to be equal A, that side is B, and the slant height is going to be C. So A squared plus B squared equals C squared. We get 36 plus 225, I think. Yep, 225 equals C squared, and take the square root of both sides, giving us approximately 16.16. That's how you find the slant height, which you need it in order to find the surface area. So the surface area of this cone is going to be the area of the base, which is the circle, pi r squared, plus pi times the radius times the slant height. 16.16. The volume is going to be 1/3 pi times the radius times the height. The volume we don't need the slant height for. It's only for the surface area that you need to find it. So if you're not looking for the surface area, don't worry about doing this whole thing here. If you don't know what the slant height is, it's not necessary. Okay, plugging in those calculations into my calculator. I mean, approximation. I'm getting for the surface area 417.71, and the volume is 94.25. Surface area is always in squared units, and this is feet. It's got one apostrophe there, so it's going to be feet squared, and the volume is going to be feet cubed. That's how you find the surface area and volume for cone.